Hi everyone. I'm going to talk through the notes in Black Book chapter 19. This is section A. Hopefully you've read it already. So this is just a confirmation of what you understood. So first things first, this whole chapter is about bivariate statistics, which means data that is associated with each other. So bivariate data, each point has two measurements or values, and you are looking to understand the relationship between the data. Usually there's an independent and a dependent variable, but sometimes it's an explanatory variable and a response variable. The first important data word is correlation. This is the relationship or association between two numerical variables. The second important piece of information in your bivariate data might be the direction. So this is visible on a scatter diagram when you plot your points. If your points are increasing in a positive direction, as your x goes up, your y goes up, that's positive. If they are decreasing, that means that as your x increases, your y is going down. That's a negative direction. And no correlation would be, or no direction would be, that they are randomly scattered throughout. The next thing you want to look for is linearity. Linearity helps you figure out if the relationship is linear or not. If the points roughly form a line, that would be a linear relationship. If there are possible other relationships, you could have, like in this case, I sort of drew a exponential relationship, but we're mostly looking for linearity. For strength, that is a measure of how closely the data follows your pattern. So if it is strongly linear, that's clearly a positive or negative trend with the points grouped tightly together. Moderate might be that the trend is clear, but the data is more widely spread. Weak could mean positive or negative direction. It's difficult to discern which, and the data is widely spread. And lastly, we have causality. Causality is whether or not the one piece of data causes the other piece of data. Just because the variables are correlated does not mean one causes the other. If a change in one variable causes a change in the other, that is a causal relationship, not casual, causal. And when causality is not apparent, you can't assume that a high correlation means causality. So just because a person is tall does not cause them to have longer arms, but those two things are related to each other. That's it.